Today we're discussing continual learning, which is certainly a trending topic in machine learning. And we're thrilled to have one of the leading experts in continual learning join us today. Josh Tobin is co-founder and CEO of Gantry. Previously, Josh worked as a deep learning and robotics researcher at OpenAI. And prior to that, as a management consultant at McKinsey. He's also the creator of the excellent resource. If you haven't used it, please check it out. It's the full stack deep learning, and Ira should be sharing that link with you shortly. And this course, some of these courses focus on the emerging engineering discipline of production machine learning, which is going to be the topic of today's discussion. And Josh did his PhD in computer science at UC Berkeley and was advised by none other than Peter Beal. Josh, welcome to the show.
Thanks, excited to be here.
Josh, great to have you. So, look, before we get into the topic today, tell us a bit about your background, your journey to becoming a researcher, from researcher to startup founder. Would love to hear more.
Yeah, so I think as you already mentioned, my background's in ML research. I did my PhD at Berkeley and was working at OpenAI kind of in the early days, back when it was sort of a pure research lab before it became, the hybrid research and product organization that it is today. And my research was focusing on how to make robots actually learn stuff that would work in the physical world, despite only being trained in a simulator. And the reason why we were working on that is because in robotics, in order to take advantage of the amazing potential of deep learning, the thing that you have to believe is that you're able to actually collect enough data to train these massive neural networks. And in robotics, it's extremely challenging because, robots are expensive to run and dangerous when they don't do the right things. And so we had this crazy idea that maybe we can actually just train them in simulation and deploy them in the real world. And it turned out to work a lot better than I think we expected. And while I was doing my PhD and working at OpenAI, I started to get sort of really curious about what's next for some of these technologies that we're working on. How do we make the leap from these really cool demos that we're able to produce in the lab to actual products that would make people's lives better? And through that investigation, I spent a lot of time talking to folks that I knew around the machine learning world who were trying to make products that were powered by this exciting new technology. And I quickly came to the conclusion that the best practices were not really there yet. There weren't really a set of engineering principles for building products with machine learning in the same way that there are engineering principles for creating software-powered products. And so that investigation led to creating full stack deep learning, which is a class that we've been running for the past 4 years or so, and is really aimed at teaching you, hey, the math and the algorithms behind this stuff. You know how to write TensorFlow code, PyTorch code, scikit-learn code, whatever it is. What else do you actually need to know in order to go from that to an actual product that's powered by machine learning? And so we teach you about how to troubleshoot when things go wrong, how to write unit tests for machine learning code, how to deploy models, how to monitor them, how to improve them continually in production. And through the community around that class, that's sort of how I ended up getting into the world of building machine learning infrastructure and tools, because I realized that there was, maybe some missing pieces that I thought we could help with.
Excellent, Josh. And we've all seen those very cool robotic training videos from Bear Lab that you're working on. And so definitely want to talk a little bit more about some of the things you just mentioned. But one thing before we get into continual learning, let's discuss what we know and probably were trained on machine learning in the first place, which is static ML models, which are one could still consider as the norm. So static or batch trained ML models, they've gotten us quite far, and that's still how, as mentioned, most people learn ML modeling. So why change that?
Yeah. So I mean, you're exactly right? When I learned how to do machine learning, the assumption that we made was someone's going to give us a data set and they're going to tell us what metric to optimize. And then our job is to, make the number go down, make the number go up. And then ultimately we beat our benchmark, and then we we ship the model, we toss it over the fence, we write a paper or whatever the outcome is, and then we're done. And that's all well and good when your goal is to produce something that works once for a demo. But that's sort of the old world, right? The world that we're living in now is that machine learning is not a toy anymore. It's a technology that companies are actually using, not just because they think it'll generate shareholder value to tell everyone that they're doing AI, not just because even there's value in making static predictions to do better planning or better analytics, but companies are actually deploying models as part of their products and the services that they offer. They're deploying models that are actually required to interact with end users. And so as soon as you have models in the real world in that way, where there is a person or a real world system that is interacting with the predictions that the model makes, then those assumptions that we're allowed to make in academia are totally out the window, right? Because in the real world, the thing that you care about is not, frankly, your users do not care if your model is state of the art on your offline data set or not. They care whether the model is part of a product that solves a problem for them. And so that means that there is a gap between the model that you trained offline and the end experience that you need to deliver to your users to solve the problem for them. And so that's why it's absolutely critical to be able to iterate on models after they're deployed in production.
No, that's excellent point. So, I've heard different descriptions of continual learning. I'm definitely guilty myself of confusing it with other techniques. And some describe it as streaming data that triggers something like a retraining workflow, and others describe it as training in, I've heard, micro batches, and obviously haven't done this myself yet. So how would you describe continual learning?
Yeah, I like to keep it really simple, which is I think of continual learning as any technique that you use to improve your model using production data. And so that's any technique that where you throw out the assumption that the model that you trained offline is the one that's going to run in production forever. And so this ranges from extremely simple to very, very complicated. On the extremely simple side, I'm not an elitist about continual learning. I think if you are, at once a month or so checking in on your model and curating a new data set by hand and retraining your model on that data set using the data that's flowing through it in production, I think that's a very, very basic form of continual learning. On the other hand, all the way down the spectrum, you might have, you might be building a click-through rate prediction model at Google and training that model on every single data point as it streams into the system, which is, extremely complicated from an infrastructure and algorithmic perspective. And then there's a whole spectrum of techniques in between. So, I think the sort of the process that you go through as you adopt this set of techniques is starting with things, just like what you do with deploying any software system. You start with things that are more manual, but easier to implement, and then you introduce more automation over time as you need it, as it becomes helpful for you to solve the problem that you're trying to solve.
Nice. So what would you say the biggest benefits of continual learning are? Like why switch to this new paradigm?
Yeah, I mean, the biggest benefits are, if you have a model that's in the real world, especially a model that's interacting with people, interacting with end users, then the model that you trained offline is not going to be very good for long in production because people's behavior changes, the world changes, and that sort of invalidates your assumptions about what the data distribution going into your model is. So this is the data drift problem, the performance drift problem. But the other, I think, more underrated reason why this is really helpful is that even if you are not so worried about drift or about degradation in performance due to changing data distributions, you are still leaving a ton of potential performance on the table if you're not using production data to make your model better. Because at the end of the day, the data that you trained your model on offline is just not the best data to actually model the task that your users care about. In production is the only place where you get the good stuff, the data that really tells you how to be really good at the task that your users care about, which is the data that they're actually putting into the system to try to solve a problem for themselves and the feedback that they're giving you on whether those predictions are actually solving their problem or not.
Right. So, we both know there's been a kind of an explosion of MLOps tools that can help one implement, perhaps help implement continual learning. But because MLOps is very focused on machine learning workflow, I don't think a lot of those tools necessarily address that. But if we were to look at some of the primary open source tools and frameworks as a practitioner that one could apply to build a continual learning system, any thoughts on that? Because I don't think there's something that springs to mind currently.
Yeah, I think most MLOps tools are focused on the model building workflow, and so they're really focused on, hey, how do we make the process of training models repeatable? Few of them are, very few, if any of them, are focused on the sort of post deployment continual iteration workflow. I think the great news is you don't have to have an advanced tool to get started with this. All you really need to do is to sort of shake the mindset that when you deploy a model, you're done. And then you can use existing tools in your toolkit to get started retraining models using production data. And then I would say, we're not an open source tool, but I think, Gantry is really the best tool on the market that is designed to do exactly this. And so obviously very biased here, but when you're ready to get more advanced, I think we're the people to talk to.
Yeah, and definitely want to talk more about Gantry in a little bit. But in the meanwhile, I would encourage people to check out the Gantry website. If you want to learn more about continual learning, I think Josh and his other colleagues there have some great blogs around that, and we'll share that link in a little bit. So what do you find, being an expert in this, having talked to, I'm sure, lots of companies about this problem and thought about it a long time, what would you say are the, because to me, MLOps is challenging enough. I think continual learning, as you're describing it, maybe an interesting challenge, maybe not. But what would you say are some of the more challenging aspects of implementing a continual learning system?
Yeah, I think there's two main challenges. One is data infrastructure. So just how, a big part of this is sort of marshaling data from point A to point B, getting it from your production stream back into your training process in a way that is, scalable and version controlled and auditable and repeatable, just in the same way that our offline ML workflows should be. So that's the first challenge. And then the second challenge is evaluation. So every time you retrain a model, it introduces risk. There's the risk that there's some bad data that's injected into your training process that's going to break your model. There's the risk that your model is going to improve on the new data that you train it on, but will actually regress on older data that is not part of the training process. There's the risk that your model will that there's potentially some new bias in the data that doesn't even show up in your aggregate metrics. And so the other big challenge, especially as you move to more and more automated and tighter and tighter, like shorter and shorter feedback cycles for continual learning, is to make sure that you have a sort of really systematic evaluation framework in place.
Yeah, so that's really interesting. So these are all problems that are associated with any system, right? Data quality and whatnot. So people talk about technical debt in software engineering, and there's been quite a few papers over the years about technical debt in machine learning. So do you find that this is that it increases the cost of the technical debt in machine learning, or in some cases may decrease the cost because of good practices?
Yeah, I think continual learning, if implemented correctly, greatly decreases the technical debt of machine learning systems, because I think one of the some of the biggest sources of technical debt in machine learning have to do with the difference between offline and online systems. Training serving skew, and also, like, one of the big sources of technical debt in machine learning systems is just the classic problem of, we have one person on our team that knows how to train this model. They trained it in a notebook, and they deployed the model. We don't really know if it's working, but no one's complaining about it. And so we're afraid to touch it. And then this person leaves, and this becomes this sort of this ghost code that is that everyone is afraid of, because it seems to be holding the system together, but who knows whether it's actually really doing what it's supposed to be doing. And so by implementing continual learning, even like very basic automated forms of continual learning, you sort of force yourself to I would really think of it as like building maintenance workflows for your models that I think greatly reduce the technical debt introduced by machine learning systems.
No, very insightful. Just want to take a question from one of our audience members here, Josh, from Charles. And as you can see there, I'm just going to read it out. Any experience in automating feature engineering modifications if needed, i.e. If patterns in recent incoming data require creating new features and are omitting old ones? Yeah, interesting question, Charles.
That is a really interesting question. I haven't seen too many folks that are really automating this part of the process. I think of this rather than jumping straight to automation. I think a concrete next step that a lot of companies can take that gets them closer to what you're describing is having structured workflows around modifying features at intervals in response to production data. So if you think about continual learning as like an outer loop on the machine learning system, where you have data flowing into the system constantly or on some period, you have and then you use that data to trigger retrainings you enrich that data, you use it to trigger retrainings, and then you evaluate the retrained model, potentially deploy it, and then make sure that it works in production. It's kind of this outer loop on the training process. Then I think of using the signals that you're seeing from production, like are all of my features working? Are there any new features that we need to introduce, as sort of like a form of observability that you should think of as like using to tune the continual learning process. And so I think the sort of step towards being more structured here is first by introducing a workflow where you look at signals to tell whether you need to add or remove or change any features on a regular basis, potentially in response to signals from the system. And then you still make those changes manually, but sort of fold them into the continual learning system in a repeatable way. And I think if you start there, then you might start to see opportunities for places where there's certain operations on your features that you do frequently enough that, hey, we can just introduce an automation for this.
Yeah, and that actually makes me think with continual learning versus, say, something like AutoML. So you have an AutoML system which is doing feature selections, some feature engineering. Do you see, like, just thinking of this question, do you see AutoML playing a role in continual learning? But on the other hand, I know you were saying earlier that doesn't have to be necessarily a closed loop stream, but with feature engineering on the fly, that can be a scary prospect for a lot of use cases, right?
Yeah.
I guess I'm asking two questions in one there about, doing feature engineering on the fly, and how do you do that in real time in production when you're more worried about good models gone bad, model drift, data drift, and all that good stuff, and doing that real time versus where AutoML plays into this? Because it's almost like at a certain point you're going to be worried that the tools can get ahead of the can get too far ahead of the modeling, almost, where you can introduce more risk to your process.
Yeah, for sure. I think so maybe focusing on the AutoML piece first. I think of AutoML as being sort of orthogonal to continual machine learning. So AutoML, a prerequisite for having an automated continual learning process is to have a repeatable way of training models. And AutoML is one. So that's like, you can think of that as a black box in the continual learning system, which is, given a new data set, how do I turn that data set into a model? And AutoML is one of the things that you can put into that black box. So you could be doing automated feature selection and, running testing a bunch of different model architectures and selecting the best one. Or you could just be retraining the same model that you retrained before. And that's sort of that's a judgment call based on the specifics, like that data scientists are well equipped to make based on the specifics of their problem. And so, generally speaking, I think of like, it makes more sense to think about AutoML when you're in sort of the prototyping phase of like, how do we get to a first pass answer at this question, at this problem? But your second question is, I think, really spot on, which is, how do you know, like, let's say that you do have a more complicated process of building a model that, we are doing feature selection, we are testing a bunch of different architectures. How do you build confidence that you're going to produce something good at the end of that? And that's why I think evaluation is sort of one of the two biggest technical hurdles that most companies face when they're moving towards more and more automated continual ML, because you can very easily break your model by retraining it on bad data. And the more complicated your training process is, the easier that is to happen. So I would say, a best practice here is, when you're getting started, if you're retraining, not too frequently, then it's a good idea to have a manual step in the process where you essentially audit the new model that's being produced to tell whether it's doing the things that you expect it to be doing. And as you, over time, as you and your stakeholders build up a shared understanding of what good model performance looks like, you can start to encode that into unit tests, where, in many cases, you'll just be able to automatically tell whether that model is good enough to go into production.
And I guess, Josh, like a follow-up thought on that is, it seems like continual learning systems, they rely heavily, well, in one use case, on streaming data, right? And so obviously, as you just mentioned, the challenge there is, how do you label, how do you annotate that data? Are techniques like active data and semi-supervised learning, are they helpful here, or what have you found in your experience?
Yeah, absolutely. I think, one of the challenges you might face, depending on the structure of your problem, is you might have more data than you can possibly annotate or retrain on. And so that's one of the steps in the continual learning loop is, hey, we have this potentially infinite stream of data that's going through our model in production. We don't have an infinite labeling budget. So what subset of our data should we sample and enrich with labels or any other data that we need in order to train the model on it? And active learning and techniques like that are an effective way of sort of answering that question.
And in your experience, who is using continual learning? Do you find there's a different companies and different industries are adopting it? Is it more the early adopters? Is it say companies in industries like retail, online retail, e-commerce, finance versus say in healthcare? Any insights on that?
Yeah, I think it's the sort of early adopters here are companies where or use cases where data changes quickly, and so it's things like fraud, right? Where you have potentially adversaries that are attacking your model to try to find ways to exploit it. So that introduces very rapid changes to your data distribution. Or it's industries like e-commerce, where consumer behavior shifts all the time. So I would say those are sort of two examples of earlier adopters for these types of techniques.
No, those are great examples, and we do have ML safety has been a track since I think last year at ODSC, and definitely one that's very heavily covered by the academic conferences. Yeah, and you mentioned earlier, I believe, talking a little bit about online learning, and again, something people may be confused about, but what's the difference between online learning and continual learning is?
Yeah, I think of online learning as learning on each data point as it streams in. Whereas continual learning doesn't necessarily need to be online. Online learning, I think of as sort of a subset of continual learning. Continual learning could also be, I retrain this model once a month.
So you wouldn't be so worried with hidden feedback loops in continual learning as you would be, say, with online learning? Would that be fair to say?
Yeah. Well, hidden feedback loops can be an issue in any type of continual learning, right?
True.
Because you can,
Yeah.
even if you're not training your model too frequently, you might have you might have bias in the data that you are retraining the model on based on the way that the model is influencing the world. And so that's sort of one of the ways that you can create a hidden feedback loop where, the model recommends you certain items that makes you more likely to click on those items, and that means that you have more data about those items to retrain the model on. So that's something always to worry about anytime you're thinking about retraining a model. I would say it's probably a bigger issue. It's certainly a bigger issue in online learning because you just have a much tighter loop to where you can actually things can go off the rails much more quickly before you have a chance to test whether they're actually working.
Very good to know. And again, I would recommend people check out your blogs on your Gantry site, because I believe it was one of those blogs I was reading one last week about the difference between retraining versus refitting models, which is an interesting concept. Can you expand on that? For continual learning, is it more about retraining or refitting models?
Yeah, I think continual learning again is like just any time when you're using production data to make your model better. And sometimes this is just retraining to deal with sort of run-of-the-mill day-to-day drift in the behavior of your users. But I think a very sort of underrated thing to do is to use your production data to almost to guide your product roadmap for how to make your model better. So to find underperforming segments of data, underperforming user segments, underperforming input segments, whatever it may be, and then guide your model development process to try to make those users' experience better.
No, and I love that concept because this is really what machine learning should be about. So I think it's a paradigm that's a lot of people are going to adopt. And on this show, I think it was just 2 short weeks ago, we had a discussion with Alex Ranther about data-centric AI on this show. So Andrew Ning came up with that term. Was it last summer 2021? I've always considered myself very data-centric, regardless of AI or not. But do you think that's going to help drive the adoption of continual learning?
Absolutely. Yeah. I think of data-centric AI as the concept that you can make your model better by making your data better. And, so I think continual learning from production data is one of the sort of most concrete and most beneficial applications of that concept, because what better data to use than the data from your end users that tells you exactly what they care about. So I think these are very complementary ideas.
Well, I think we can term a new coin, Josh. We can call it production-centric AI.
There we go.
Steal one on that. I'll take co-credit on that.
I'll steal that. Yeah.
Go right ahead. We owe you for sure for speaking at ODSC so many times. But listen, we're coming up on the 35-minute mark. But I do want to spend some time talking about your startup, which I think is quite fascinating. You raised a seed Series A combination, and for people who are not in the startup world, going from raising a seed plus a Series A together, that's quite impressive. That was quite an endorsement. I think the round was 28 million plus. So what inspired you? Talked a little bit about the startup, but 2-part question. What really inspired you to go out on your own, take that risk? OpenAI is a great company. I hear they pay pretty well there. And what problem are you focusing on with your new startup?
Yeah, I think really for me the inspiration was a couple of years ago. I started to, we had this sort of front row seat into how people were trying to apply machine learning in the real world through full stack deep learning. And a couple of years ago, I noticed a pretty dramatic shift in our student body, which was, when we first started teaching the class, most of our students were researchers who were, looking to have more of an impact or maybe get their first job in industry, or there were software engineers who were thinking about changing careers into ML. But suddenly in, let's say, like late 2019, early 2020, our students started to be ML engineers, which was barely a role that had existed 2 years before that. And more than that, these folks were building real stuff. They were building, not just off in the corner of their organization building prototypes or doing research, but they were actually building real product features that were powered by machine learning. And so to me, it's felt like this is an inflection point as a field where, for the past 10 years or so, frankly, like most companies invested in machine learning without really getting value from it. They saw the promise of it, or maybe they saw the hype of it, and they built machine learning teams in response to that. But now there's tons of companies that are sort of building more and more machine learning powered features into all of their product offerings. And I just really wanted to be part of that transition because I think machine learning is going to become part of pretty much every product or service that every company offers over the course of the next 20 years or so, much like software has over the last 20 years or even longer. And I think it's sort of an incredibly profound technological shift. And I really want to just have an impact on that. And as for why, start a startup around it, I just looked around and I didn't really feel like anyone was really answering what I thought were some of the most important problems that needed to be solved in order for machine learning to have the kind of impact that I think it can have.
No, excellent point, Josh, and definitely something we noticed as well in the last 3 years from ODSC around 2019. This focus to production machine learning and a lot of challenges around it still, right? I think it's an extension of the issues we saw with software engineering, which a lot of projects by different project management criteria never make it to production, and even the ones that do make it to production, they fail in other criteria, right? So I really think this ML ops, machine learning workflow, everything you're working on, continual learning is going to contribute significantly to the industry because the workflows are definitely getting more complex, and I think that's great as well. And as an engineer myself, I'm a big fan of open source tools, as everyone knows, but at ODSC every year we're always focusing on build versus buy because sometimes you got to figure out how best to service this. So I would highly recommend checking out Gantry and tracking what Josh and his team is building over there because I know it's something quite special. So Josh, just to wrap this up, you're going to be speaking in 2 short weeks at ODSC West. Tell us a little bit about your session there.
Yeah, I won't spoil it too much, but we'll definitely be talking entirely about continual ML and going to more detail than we were able to get into today. So come check it out; it should be interesting.
Well, Josh, thank you so much for being a good sport, for speaking at ODSC in the past, speaking at ODSC in a couple of weeks, for coming on the show, and fantastic insights.
Thanks so much.
Got some valuable insights like I did from that conversation. Very, very interesting, and looking forward to meeting you in person, Josh. So we'll see you in
me too.
In a few short weeks.
I'm easy to find online, so if anyone listening wants to continue the conversation, just feel free to get in touch. This is basically what I spend all of my time thinking about these days, so I'm always happy to chat.
Excellent. Thank you so much for that. And I believe we shared the link to your website as well, and follow Josh there on his blog site on LinkedIn as well. Okay, thank you so much, Josh.
Thanks.
Appreciate it. Bye now.